guys. So this week we are going to be talking about factoring. So I'm introducing you to this concept of factoring. I'm going to go through the notes that I have posted, so hopefully you'll have them with you as I do it. So there's really three types of factoring we're going to talk about. Today, for the first worksheet, it's the greatest common factor and then what we call grouping. These are two different types of factoring. So greatest common factor, this factor could be a number, a variable, or both, right? So a factor could just be a number that they have in common. A factor could be a variable factor that they have in common, or you could have both a number and a variable. So I give you a couple of examples here. So in this expression, 15p plus 25, they both don't have variables. So if I just look at the numbers 15 and 25, I write out here the largest factor that they have in common is 5. So when you are factoring out a common factor, you put the greatest common factor on the outside of a parentheses, and then inside the parentheses, to find what's left, you're going to divide each term in the expression by the greatest common factor. So 15p divided by 5, that gives me 3p. And 25 divided by 5 gives me 5. And this is what I end up with. Now you can always check to make sure you were right by distributing back in, and just make sure that if you were to multiply back in, you would end up with the expression you started with. Okay, just make sure you don't write that as your final answer. This is your factored form. Factored means it's two things you're multiplying together. That's why we call it factoring. So I'm multiplying the 5 by the 3p plus 5. Okay, a second example over here, there's three terms here in this trinomial. They don't all have variables, so they don't have a variable in common, but 6, 12, and 27, the greatest common factor of all of them is 3. So I put the 3 on the outside, and then I divide each of these terms in the polynomial by 3, and that's how I end up with what's left inside the parentheses. Okay, in this example here, you'll notice 12, 8, and 10, they all have a greatest common factor of 2, but they all have an x in common. So when they all have a variable in common, you're going to take out the smallest exponent on the variable. So the smallest exponent here is 1. So 2x is the greatest common factor that goes on the outside, and then I divide each of these terms by that GCF. Now I put in a little asterisk here. Just remember what you learned about exponents, that when you divide x to the third divided by x to the first, you subtract the exponents. 3 minus 1, that's what gives me 2. 2 minus 1, that's what gives me 1. And then x divided by x, the x's cancel out, and that's why there's no variable on this one. Okay? So I have, remember down here, remember when dividing bases, they're the same, you're subtracting those exponents. Okay? All right, so then on the bottom here, some other examples that 45 and 60. And I have, be really careful here, because you'll notice that 45 and 60, you might think, hey, they both have 5 in common. And 5 is a common factor, it's just not the greatest common factor. So you want to make sure greatest means the largest. So 15 is the largest factor they have in common. They both have a y. The smallest exponent is 4, so that's why I took out y to the 4th. Then when you divide each term in the polynomial by the GCF, you will see what you're left here. Now, another way to make sure you did it right is whatever is left in parentheses, make sure that whatever is left doesn't have any factors in common. So they shouldn't have any variables in common, and they shouldn't have any number factor in common. Okay, and then the last thing I want to remind you about with the GCF is that if the leading coefficient is negative, you have to take the negative out with it. Okay, so in this case, 8, 24, and 4, the greatest common factor is 4, but since the leading coefficient is negative, I'm going to take out a negative 4. And they all have a c, smallest exponent is 1, so the GCF is negative 4c. So then when I divide, just make sure you're paying attention to a negative divided by negative, that's why I have a positive here. A positive divided by a negative, that's why I have a negative here. So pay attention to your signs as well when you're doing those problems, okay? All right, so then on the second sheet of notes, greatest common factor might not just be a number or a variable, but it could be an entire parentheses. So in this case, in example 6, you really have two sides, and I kind of underlined them here. You have this minus this. So these are two parts of that polynomial. They both have a b minus 2. That parentheses is what they have in common. So my GCF is actually this quantity b minus 2. So when I write that, I have to keep it in parentheses. And then I start my parentheses for what's left. Well, when I divide this by b minus 2, I'm left with y. And when I divide this by b minus 2, I'm just left with the negative 6. And so that's why this is what you end up with. Okay, so again, read through some of my notes here. Over here, another example, these both have an x plus 1. They have an entire quantity, parentheses, in common. That GCF has to stay in parentheses, and then you start a parentheses for what's left when you divide. Okay, we need to know this because this is going to help us with our second type of factoring, which is factoring by grouping. And you're only going to use this when you have 4 terms in your polynomial. Okay, so an example here, there are 4 terms here. So if I'm going to factor by grouping, I put the first 2 terms together and then the second 2 terms together. I'm going to take the GCF out of each. So the greatest common factor of this group is x. And I'm going to take the x out, and then I'm going to divide each of these terms by that x to see what's left. And then the GCF of this group is a negative 6, again, because for this group, the leading coefficient is a negative 6. So when I take the negative 6 out and divide each of these terms by that negative 6, this is what I'm left with. Now, I'm not done yet because I don't have 2 things being multiplied together. I'm not done factoring. But now what I notice is that each of these has a quantity x plus 3 in common. So the GCF is the quantity x plus 3, and then in parentheses, when I divide each of these by x plus 3, I'm left with x minus 6. This is my factored form because I have 2 things being multiplied to each other. Up here, no, this is not factored yet. This is getting me to that factored form. Now I know factoring by grouping works as long as when I get to this point, I do have a parentheses, a quantity that I can take out. So same idea here. I just walk you through this example again of factoring by grouping. Example 3 on the bottom, what I want you to be careful of is make sure you look for a GCF first. So before I group right away, I'm going to say, hey, wait a minute, all of these have a 3 in common. So I'm going to take the 3 out first, just like we did in the previous examples. And then I'm going to group what's left, those 4 terms. I'm going to take the GCF out of each group, and then I'm going to see I have a parentheses, a quantity in common. I'm going to take that out. Here's what's left. And then we just have to make sure we take that 3 we took out at the beginning, has to be written at the end in front. Okay, so you want to make sure you do that as well. Okay, so then the second sheet that I'm going to give that you guys have to do is a third type of factoring, and it's called Unfoil. You know FOIL, I talked about that before when you multiplied polynomials last week, first outside, inside, last. Well, we're going to kind of reverse that process. Now, you're only going to use Unfoil when you have 3 terms and the leading coefficient is 1. This is the only time you can use this process. So it's going to look like this. Leading coefficient is 1. Doesn't matter what this coefficient is. Okay, and then what you're going to basically do is ask yourself these 2 questions. Find 2 numbers that multiply to C, that multiply to the constant, and add up to the middle coefficient. I need 2 numbers. So in this example, I write out for you, okay, what multiplies to a negative 15, the constant, and adds up to 2, which is that middle coefficient. Well, 2 numbers that do that are 5 and negative 3. And so all I'm going to do then is put 2 sets of parentheses, put the variable you're working with, in this case x, just put x here, and then the 2 numbers you come up with can go in either one. So I could put plus 5 minus 3 or minus 3 plus 5. That doesn't matter. And again, you can check your work on this. I could FOIL this out, and as long as I end up with the polynomial I started with, then I know I did it right. Just make sure you're circling your answer. This is the factored form. Factor means things that are being multiplied together. Okay? The second example I have here is y's. So it's find 2 numbers that multiply to negative 20 and add up to a negative 1. And so in this case, my 2 numbers are a negative 5 and 4. So again, I put my 2 parentheses, but this time the variable I'm working with here is y. So I put the y first, and then I put my 2 numbers that I came up with in the parentheses in either order. Okay, in example 3 here, just like before with grouping, I said always make sure check for your greatest common factor. So in this case, my greatest common factor is a negative 4. Now it's negative because the leading coefficient is negative. So I'm going to factor out a negative 4, and I'm left with this trinomial. Well, when I'm left with a trinomial and the leading coefficient is 1, then I'm going to have to try the unfoil. Are there 2 numbers that multiply to 3 and add up to 4? Well, I did. There's 3 and 1. Okay, so I'm going to put my 2 parentheses, plus 3 plus 1. Just remember to bring that GCF down. Okay. In example 4, I just needed to take a negative 1 out. And then I could do the unfoil. Don't try to unfoil when that leading coefficient is not a positive 1. Okay, so I took a negative 1 out. Then I could go through my steps to unfoil, and you can read through those. Okay, and then in example 5 here, again, I took a 2x to the third out. So I had this GCF, I had to take that out first, and then walk through my questions. Now, sometimes you're going to find that you're going to find more than 2 numbers that multiply to a product. For example, if you take the number 12, well, 2 times 6 is 12, and 3 times 4 is 12, and 1 times 12 is 12. But you want to make sure the 2 numbers you pick that multiply to the constant have to also add up to the middle coefficient. So keep that in mind as well. Okay. All right. I know this was kind of quick. I wanted to just kind of walk you through these notes I gave you. Take the time to study the notes and then have them with you as you're working on those 2 worksheets, okay? Try not to look at my answer key for the worksheets until you've really tried it on your own. It's the best way to know if you really know it or not, okay? So good luck with that, and if you have any questions, just send me an email.